So this is question number 9. This is question number 9. Draw the projections of a circle with 30 mm diameter. It is inclined at 45 degree to VP and perpendicular to HP. The center of the circle is 40 mm above HP and 25 mm in front of VP. So you see here that it is a circle 30 mm diameter, but it is inclined at 45 degree to VP and it is perpendicular to HP. So we will now see the explanation part of this. Here in this question it is mentioned that the circular plane is perpendicular to the horizontal plane, which is similar to the question which we have seen, that is question number 7. So now the position of the circular plane is in such a way that it is perpendicular to the horizontal plane and parallel to the vertical plane, because when you see it from this side, you see that this blue colored is a vertical plane, and this circular, which is appearing as a line, is going to be parallel with this plane. But the trick here, the most important thing here is that there is an angle which has been given with respect to the vertical plane. So I have to tilt this with respect to the vertical plane. Now you see that I am tilting this square circle with respect to the vertical plane, and in any case angle whichever I am making is being with the vertical plane. So I'll show you now. Just take this angle. Now this case is perpendicular to the horizontal plane. But when you view from the top, this square line which was a straight line earlier, now it's appearing at an inclination angle. And the front view will be very interesting here. You see that there will be a circle, portion of a circle, but now it has been appearing, now it will appear as a ellipse. Yes, you see that. So first we will assume that it is parallel to the VP and perpendicular to HP. So we'll get the front view as a circle. This is similar to the previous question, that is question number 7. Our front view will be a circle. And as it is mentioned, the center is 40 mm above HP. So this is 40 mm. And this is XY line. And it is 25 mm in front of VP. So this is 25 mm. So our assumption is finished now. Like when it is directly perpendicular to HP and parallel to VP, we'll get the front view circle and this line as is the top view as a straight line. But here we see that, here in this question we see that it is inclined at 45 degree to the HP. So I will take any point here and I am taking an angle of 45 degree. So this length should be taken by measuring this, which would be 30. And I am taking H pencil here. And to get the top view, we have to project lines from this. To get the front view, we have to project the lines from the front view as well as this top view. So we have divided the circle and we have projected these points as 1 dash, 2 dash, and we have taken the same point by taking the compass, as you have seen, by taking these distances and cutting the arcs here. We need to take this same lines above, projections of these lines. It's looking like a little bit messy. Don't worry, it will all make sense in a moment. So now you have to match the points. This is the first point here, this is the 1 dash, so you will get 1 point here, and this is the second line and second point, 2 dash from here and 2 from here. Similarly 3 dash, 4, 5, 6, 7, and then here you have 8. So here 8, 9, 10, 11 and 12. So with free hand I can easily join this now to get the ellipse, which we have seen earlier, that if a circle is tilted at an angle, the view will be a ellipse. So this was our exercise number 9. This is the front view and top view. Thank you. This is exercise number 10. Draw the projections of a regular hexagon with 30 mm side and it is perpendicular to VP. One of the edges is on HP and inclined at 40 degree to it. So this is a little bit trickier question, but not tough, because it's just a regular hexagon with 30 mm side. It is a two-dimensional figure, a hexagon. That's it. But it is perpendicular to the vertical plane and it is inclined at 40 degree to the VP. So make sure that you have to imagine this hexagon with inclination with respect to the horizontal plane. So we'll see the explanation part now, and after that I will do the exercise in the drawing sheet. Now in this question, hexagonal plane is given. Hexagon is given in simple terms, but it is given with an inclination angle with respect to the horizontal plane. Now as on your screen you see that this horizontal this hexagon is resting directly on the horizontal plane. So when I view when viewed from top, this will appear as a hexagon directly resting on the horizontal plane, but there is an angle of inclination which has been given. So you see that now I am making an angle with respect to the horizontal plane, and in any case of this rotation, this is going to be perpendicular to the vertical plane, because you see that whenever however I keep the hexagonal plane, from the front view it will appear as a square. Front view means from this side. So let us tilt this object in this position. Oh, sorry. So I have tilted this object. Now I will delete the planes and extra lines, so that it will become easy for you to imagine. So now when we view it this hexagon from the top, it will appear as a hexagon itself, but you see that its length has been contracted, and when it is viewed from the front, there will be a only straight line. Make no mistake, there is a straight line which is being appearing from the front. So this is the position of this this is the position of this hexagon with respect to the horizontal and vertical plane. It is being perpendicular to the vertical plane and it is inclined to the horizontal plane. So its top view will appear as a contracted hexagon and front view will appear as a line. So we'll first assume that this hexagon is just lying on the horizontal plane and it is perpendicular to the VP. So to draw the hexagon first, drawing arcs. By joining these lines. So this completes our hexagon. It is not mentioned any distance from the VP as it is lying on the HP itself. So if this is the XY line, the front view will come on this XY line only. And I will name this as A, B, C, D, E, F. So this point becomes A dash and B dash. This as F dash and C dash. This as E dash and D dash. Now what I will do is I will tilt this line. I will tilt this line of 52 mm. I am getting this length as 52 mm from here to here, and the angle of which is given in the question as 40. So the angle is 40 and this length is 52. But now here you can observe that I will use the H pencil because this is the final front view of this figure, and I will mark these other points also at the center as we did in the previous question. This is A dash, B dash, F dash, C dash here, and E dash, D dash here. To get the top view, projections from the front view and this top view. So you can easily get that A to A, then B, B dash, C, C dash, E, E dash. In this fashion you will easily get a shape of contracted hexagon. This is the contracted hexagon. This is the final top view of our given figure. So this was our exercise number 10 of. Thank you.